Hello everyone, I welcome you for the next lecture on the computer graphics and visualization. So in the last class we have discussed about graphics networks, graphics on the internet, graphics software. So today we are going to discuss about introduction to OpenGL and basic OpenGL syntax and some related libraries and what are all the different types of header files and how to consider the display of window and its management using GLUT and one simple example program, complete OpenGL program. So with this you will be able to understand the basic concept of OpenGL. So OpenGL is a basic library or OpenGL is a library. So which is going to have a set of functions provided by in OpenGL for specifying graphics primitives and attributes, geometric transformations, weaving transformations, and many other operations. As we noted in the last section, the OpenGL is designed to be a hardware dependent. So many operations such as input and output routines are not included in the basic library. However, these input and output routines and many additional functions are available in auxiliary libraries that have been developed for OpenGL programs. So first let us understand the basic OpenGL syntax. So all the function names in the OpenGL basic library are going to be considered from OpenGL core library. Each and every function is going to be prefixed with the small case letter GL. And each component word within a function name, each component name or component, whatever it is using that component word within a function name which has its first letter capitalized. So let us see one example how actually the functions are going to be start. Here you can see which is going GL begin is a one function in OpenGL. So GL, which is all the functions are going to start with the letter GL, small case letters. And begin is a function. The first letter of the function is always should be in a capital. So GL begin is a one function. And same thing here, GL clear, first letter capital, GL copy pixels, GL polygon mode, and many more. So try to remember here all the functions defined in the OpenGL library are going to be start with the letter GL, and the function name always it should be considered with the capital case letters. Even it has a certain set of functions that are going to require that one or more of their arguments to be assigned as a symbolic constant, and which is going to specify some parameter name and value for that parameter or a different mode and all those things. So such type of functions are going to be begin with the uppercase GL. So in the last slide we have studied about the small case letter GL. So that GL we call it as an GL functions. Next here these are the certain set of functions which is going to have a some parameter name or parameter symbolic constant as such. So for that such functions are going to be begin with the capital case letter GL. So these two are capital case or uppercase. In addition with this, the component words within a constant name are written in capital letters, and the underscore is used as a separator between all component words in the name. So the following are some few examples of several hundred symbolic constants are there which are available with OpenGL functions. So these are the some examples of symbolic constants. So these symbolic constants are used as a parameters to the different functions, and these parameters are going to be start with the capital case GL underscore and the name of the function. So GL underscore 2D. This is a one parameter. This will be passed as a symbolic constant to the function. Same thing GL underscore RGB, GL underscore CCW, GL underscore polygon, GL underscore. If there are more than one words, and each and every word will be separated with underscore. So there should not be given any space between the two words like ambient and art. So that should be given with underscore. Here two or more words. If there is only one word, one symbol, one underscore is sufficient. So these are the different symbolic constants that can be used for use in the OpenGL. And these OpenGL functions are going to be considered with some specific data types. For example, an OpenGL is a function parameter which is going to have the value specified as a 32-bit integer. And the size of an integer specification can be different on a different machines. Already you know about this. Some integer it may hold 16 bytes and this one 16 bits and other one 32 bits integer and all. So this is going to be depend upon the different on the different machines. So to indicate the specific data type, OpenGL has a special built-in and data types names. So which is going to have a set of built-in data type names. So those data types are same as that of the our normal programming what we use, but each and every data type is going to start with GL, capital G, and this one capital GL. So GL byte, GL store, GL int, GL float, GL double, GL boolean. So these are the different data types used in the OpenGL library. So each data type name begins with a capital letters. Try to remember here each data types are also going to be start with capital letter GL int, and same thing GL float. So like this which is going to be start with, and then remainder of the name is a standard data type designation which is going to be written in a lowercase letters. And some arguments of OpenGL functions can be assigned values. So using an array that is going to be list at a set of data values. And this is an option for specifying a list of values as a pointer to an array rather than specifying each element of the list explicitly as a parameter argument. So the typical example with this option is specifying XYZ coordinate value. So this XYZ coordinate value we may be specified according to the coordinate system, Cartesian coordinate system. So now let us understand what all the different libraries are there supported with this OpenGL. In addition to the OpenGL basic core library, what we have studied about some functions, some data types, these are the basic thing. And also we have discussed about some symbolic constants. So even with this, it is going to have a number of associated libraries for specific operations or some special operations. Then the OpenGL utility, there is another utility GLU, what we call it as an OpenGL utility, which is going to provide routines for setting up weaving and projection matrices, and which is going to describe the complex objects with the line and polygon approximations for displaying some curves like quadrics and B-splines and all. So which is able to have some projection matrices, and with this it is able to draw the some complex pictures and designs and all. So every OpenGL implementation includes the GLU library, that is Graphics Utility Toolkit library, and which is going to start with the name of the prefix called GLU. All are small case letters, GLU. So there is an object-oriented toolkit based on the OpenGL that is called as an Open Inventor, which provides routines and predefined object shapes for interactive three-dimensional applications. And normally this toolkit is written in C++. So to create a graphics display using some OpenGL, we first need to set up a display window. So try to remember this. We first need to set up a display window on our video screen, and simply this window will be a rectangular area. This is a rectangular area on the screen in which our particular picture will be get displayed. Say for this one. So in the monitor, there will be some part of the rectangular area we used to create. So within this rectangular area, which is able to draw the picture from the total monitor. So we cannot create a display window directly with the basic OpenGL functions, since these libraries are going to have only one device independent graphics functions and window management operations. which is going to depend on the computer what we are using. However, there are several Windows system libraries that is going to support with OpenGL functions for variety of machines. And in the OpenGL, there is a extension of the X Windows system, that is GLX, which is going to provide a set of routines that are prefixed with the letter GLX. So it is going to have the set of extension of the Windows routines GLX, and Apple systems can use the Apple GL, so that we call it as an AGL interface for window management operations. So these function names are going to be prefixed with the AGL. And the Microsoft Windows systems, there will be a WGL routines providing a Windows to OpenGL interface, and these routines are prefixed with the letter WGL. So Microsoft Windows routines. And there will be another interface called a Presentation Manager to the OpenGL PGL, which is an interface for IBM OS and which uses the prefix called PGL for the library routines. And another type of toolkit what we have is OpenGL utility toolkit, that we call it as an GLUT, GLUT. This OpenGL utility toolkit we are using for our Windows operating system for providing any of the graphics application. So this toolkit is going to provide a library of functions for interacting with any screen windowing system. So whatever the screen we have, the window, so depending on the screen, so where exactly you want to display the image, so everything will be considered within a window, so it is able to have a screen windowing system. So that GLUT library are to be prefixed with the GLUT. Each and every GLUT library are going to be prefixed with GLUT, and this library also contains some methods for describing and rendering curves as well as surfaces. So this GLUT is considered now as an interface. Graphics library utility toolkit is an interface to other device specific Windows system. We can use it so that our programs will be device independent. Information regarding the latest version of a GLUT and download procedures for the source code are available at the following website. So you just refer to this website, and even you can download the GLUT library freely from this website. You just go to this and you can download the GLUT. And which now we are going to see, once if you are installed with the GLUTs, what all available things are there with the OpenGL utility toolkit. The first and foremost thing is related with the header files. In all our graphics programs, we need to include the header file, because we are going to write the now C++ program to create some graphics application. So we need to include the header file for the OpenGL core library. So for most of the application, we will also need a GLU, and many systems we will need to include the header file for the Windows system. So for instance, the Microsoft Windows, the header files that access the WGL routines is normally given in a windows.h header file, and the header file must be listed before the OpenGL and GLU header files, because it is going to contain some macros by the Microsoft Windows version of the OpenGL libraries. So these are the main header files are going to be consisting with the OpenGL toolkit, that is windows.h, gl.h and glu.h. So if you want to include any of these libraries, so that can be preceded with the hash include. These are called as preprocessor directives, and include the library. So however, this use of GLUT is going to handle the window managing operation. So we do not need to include gl.h, glu.h, because GLUT ensures that will be included correctly. Thus, we can replace the header files for OpenGL and GLU with this header file gl-glut.h. In addition, we will often need to include a header files that are required by the C++ code. So this C++ code, which is going to be start with the stdio.h, stdlib.h and math.h according to our requirement of the functions. So next very important thing is about the display window management using GLUT. Very important thing. We need to understand now how exactly the display window management using GLUT can be handled. To get started with this window management, we need to consider very simplified and a minimal number of operations for displaying a picture. Since here we are using the OpenGL utility toolkit, that is GLUT, the first step is to initialize the GLUT. So that initializing the function which is going to process any command line arguments, and these are going to help for the parameters for our example programs. So here we will not need to use these parameters for our first programs, but whenever you are going to have some command line arguments, that also can be handled. So we perform the GLUT initialization with the statement function called GLUT init. So these are all the GLUT functions. So GLUT functions are going to be preceded with the GLUT and function name, which is going to be preceded with first case capital letter, first letter capital case, and the number of parameters. So this is GLUT init, which is the initialization function, could also process any command line arguments, but we will not need to use as a parameters for our first example program here. So once the initialization is being done, so now the GLUT initialization is done. So we use for initial purpose GLUT init with the command line arguments. Next we can state, this is the first step what we have done. Second step is to display the window is to be created onto the screen. As I already told, onto the monitor exactly, first you want to create the window having some minimize operation, maximize operation and close operation. Within that window, if you want to draw the picture, so that thing is to be handled with the creation of the window. So that can be accomplished with the function called GLUT create window. And whatever the name you want to give for that particular output with display window, so that can be given in a double quotation, an example of OpenGL program, where the single argument for this function can be any character string that we want to use for the display window title. So this can be considered as a display window title. Then we need to specify what the display window is to contain. For this, we create a picture using OpenGL functions and pass the picture definition to the GLUT routine. So this is a third step, that is when we create a picture. So whatever the picture we are creating, so using some OpenGL functions, so that picture definition will be sent for the display window. So we need to specify that the display window should contain the whatever the picture definition can be done with the OpenGL functions, and that can be handled with some GLUT routine. So for that we use a function called GLUT display function, which is going to assign our picture to the display window. So if I want to draw the tree, something like this, so this needs to be get display on to the particular window. So this picture definition will be sent to this particular window. So that thing will be handled with a routine called GLUT display func. And as an example, suppose we have the OpenGL code for describing a line segment in a procedure called line segment. So now with the argument for the GLUT display function should be the name of the function, what exactly you want to draw. If I, for example, if I want to draw the line, so the name of the function to draw the line should be passed as an argument. Next, the following function call, which is going to pass the line segment and description to that particular display window. So for that, GLUT display func, and which is going to consider to the line segment. So this line segment is a function name or a function routine passed as this should be defined with the drawing of a line with some two coordinates and all. So this should be the argument for GLUT display func. Next, once this is done, display window is not yet on the screen. We need to do one more GLUT function to complete the window processing operation. After execution of the following statement, all display windows that what we have created, including their graphic content, should now activated. That thing can be done by using the function called glut main loop. So this will be the last function of the main function. So this function must be a last one in our program, in our C or C++ program. So which is going to display what? The initial graphics and puts the program into an infinite loop that checks for the input from the devices such as a mouse or a keyboard until and unless once the graphics something if you are drawn onto the window somewhere here onto the screen and window. So here suppose tree is being drawn until and unless we close, until we give an input from the keyboard or a mouse to close this window, this should be in an infinite loop, means the window output should be always running. So that thing will be done with the help of glut main loop. So once if it is handled like closing that window or minimizing that window, maximizing that window, that will be handled with the glut main loop. So our first example will not be that much of interactive, but here we are going to see the program for displaying our picture until we close that display window. And later chapters, here we are going to consider about how to modify our OpenGL programs and to handle a interactive input. So although the display window that we create will be in some default location and a size, and even we can set these parameters using some glut function with additional function called glut init window position function. Glut init window position function, which is going to give an initial location for the upper left corner of the display window. So suppose this is a monitor here where exactly I want to place my window. So this we may be considered with the help of upper left corner of the window. So where exactly I want to display my window. Say for example, I want to display my output window here. Like what exactly the graphics I want to display. Means some x coordinate. This is what is called x coordinate and this is what is called is y axis. So x and y value. Suppose if you specify some 30 means 30 pixels on x axis and 30 pixels on y axis. So 30 pixels on x axis means this distance 30 and 30 pixels y. So that our window will be get displayed exactly entirely onto this corner at the upper left corner from the display. So this distance will be measured from the upper left corner of the window and the position is specified in terms of integer coordinates like 30 and all those things. And this upper left corner of the display window should be placed as some pixels from the right of the left edge of the screen and down from the top edge of the screen. So here this is one example what I have given, glut init window position. Glut init window position, the function name. So glut init, try to remember this function which is going to have the position where you want to keep the window onto the screen with 50 indicates which is going to have x coordinate and y coordinate. X is 50 pixels from the left, from the top left corner, and 100 pixels, here it is being mentioned 100 pixels from the down. So here exactly it may get the point according to the screen coordinates. Similarly, glut init window size is a function which is used to set the initial pixel width and height of the display window. Thus, we specify a display window with an initial width of 400 pixels, width of 400 pixel and height of 300 pixels. This can be specified by using the function called glut init window size, that is 400 and 300. Means the particular window what we have created to display the output is going to have the 400 as a height and 300 pixels width. So the window size even you can give, and according to the window size what you have given, according to that pixel size it is going to create the window size. So this is a very good example to understand about these coordinates. So 400 by 300 is a window of a particular position where exactly it has been started. So there we have mentioned in the example, this is x coordinate and this is y coordinate. From the left it is 50, from the top it is 100, and this is a window size. The window size, the name we have given is an example of OpenGL program with a size called 400 pixels width and 300 pixels height. So this is related with the exact uh, window where this is what is the output window where you want to display the graphics output. Okay, so even you can vary the size and even you can place the location. If you don't mention these x and y values, by default which is going to start with the up top upper left corner if you don't specify the position. If you specify the position, according to that it will keep the window at that particular location. If you don't mention any of the position, so by default which is going to be start with top, this one left corner. Okay, so here we'll try to wind up the class. In the next class we'll see the program related with the how to display a content onto the window. Thank you.